Under. Okay. They are sitting under. Undergrads are sitting there, isn't it? So you have been differentiated, right? Um, Now this institute is in Bangalore, right in the heart of the city, uh, close to Indian Institute of Science. We say IISc is one of the institutes everybody look forwards to go. And this comes under ICFI, so all of you must be knowing this. And ICFI has got 9 institutes all over the country. IWST is one of them, and except 2 institutes, 2 or 3, IWST, IFGTB, which is here in Coimbatore, and Ranchi, IFP. All others, they work mostly on forestry. These 3, 4 institutes have special mandate. Like IFGTB. Sorry, you have to stand in the podium. It is being recorded from the headquarters. Okay. Use the mic also. So IFGTB is basically on tree breeding. So IWST is focusing on wood science. So our main mandate is to do research on wood science. Okay. And we also have some 5 centers all across the country. And just in 2022, last year, there was an institute, Indian Plywood Industries Research and Training Institute, IPRIT. I don't know, some of you would have visited. That got merged with IWST. So now it is an integral part of IWST. And IWST, we have 4 divisions: wood properties and processing. This is where I work mainly. Um, and we also have a division on plywood and panel product technology. So like you would have seen here, you see lots of plywood made from Melia dubia, eucalyptus, and different species. So there again in this division, research, training, testing will be conducted on plywood and panel product. We also have silviculture and forest management division. Their main job is basically to deal with silvicultural aspects, particularly sandalwood, because it was a sandalwood research center. So a lot of work is being done on sandalwood, bamboo, tissue culture of sandalwood and bamboo species. And lastly, we have a division on forest protection. So they mainly look after insect pest interaction with the trees and in also with the wood. We are running PhD programs, so we have quite a few. Almost as of now, we have around 40 PhD scholars in IWST. 25 are in my division only. So we have a huge number of PhD scholars working on wood technology. Then we also run PG diploma on wood and panel products. So it's a 1 year course, and advanced woodworking. I think if you can get an opportunity to come and work there on advanced woodworking, there we have all the advanced machines like what we have here, one CNC. Similarly, we have 2D, 3D CNCs and number of high-end equipments. And extension, anyway, it's all there. And last one is standardization. All plywood, particle board, MDF, they have to have minimum standards. So we have Bureau of Indian Standard. Bureau of Indian Standard specifies that what sort of, like, whether it is a general purpose plywood, whether it is a shuttering grade plywood, whether it is a marine grade plywood, what should be the properties, what should be the adhesive strength, and everything is specified. And earlier, IPRIT was contributing significantly. Now IWST contributes significantly in developing standards or amending standards. So recently, MDF standards have been amended. They have been brought at par with international standards. Our standards were very stringent actually. Similarly, we have standards for formaldehyde emission. Most of this plywood, particle board, they use formaldehyde based adhesives. They use either urea formaldehyde, urea melamine formaldehyde, or phenol formaldehyde. Now, formaldehyde is a chemical which is known to be not good for human health. It is considered to be a carcinogenic material if it is you are exposed for long duration. So there again there are standards, so that permissible limits for formaldehyde emissions, and these standards are being developed at our institutes, and also testing is done. So this is I just don't want to go much deep into this. Like wood properties and processing division, as some of you are doing anatomy, so it's basically deals with anatomy, physical, chemical properties, value addition, wood weathering, and testing methods for timber products. And plywood and panel, I mentioned processing engineer for raw materials for developing panel products. So you develop, take different raw materials, make panel products out of it. And so can we make use rice husk for panel product? Anybody tell me? Rice husk. Can you use it for panel product? Tamil Nadu must be generating a lot of rice husk. Yes. Can we use wheat straw? Yes. So these agro residues can also be used as a source of raw material for making panel product, so that our dependency on wood becomes less. Otherwise, what happens? Rice husk, where do they use generally? Where does it go? Straw, and sometimes it gets burnt. And there was a time when rice husk was given free of cost. Now people have started charging money because it finds value. The moment you make any value added product. Okay. So that is what the importance of value added product is. By adding value, you can increase the economic value of the raw material, whether whatever material is there. And that is where our science comes into the picture, that how best we can add value to such raw material. Now, 20 years back or 25 years ago, nobody thought of using Acacia auriculae as a timber. It was planted as a fuel material. When you do little bit of value addition, now it is considered at par with tea. In Bangalore timber market, it is sold on the name of Assam tea, Acacia auriculae, because it looks like tea. You can't differentiate just like that. And its properties are as good as teak, most of them, except few. And that except a few makes a lot of difference. You know how much is teak wood cost? Anybody can tell in market? What would be the value of teak wood? At least 2000 rupees. At least 2000, 2500 rupees CFT. What would be the acacia auriculae? At that time, it was 200 rupees CFT. Now it has become 1200 rupees CFT. It's only because of the value people have realized. Okay. Rubber wood. Rubber wood, now it is used for making furniture. Do you think it's a good idea to make use of rubber wood for furniture? Yes. I have my own dining table chairs made out of rubber wood for last 20 years. Nothing has happened. They're all perfectly all right. You don't dine in the dining. No, we dine every day. Nothing has happened. Only thing is that you need little bit of processing. You add value by either giving treatment and season and then give nice finishing coating, so you increase the value of the material. So like that panel and product develop division, they do a lot of work on adhesives and product standardization testing. Then silviculture, I said we have branch. You are from Metropolium only. There are lots of couple of scientists who are working there, and they work on sandalwood, bamboo, micropropagation. Then forest protection, as I said, it talks about pest and disease of trees. I don't have much idea on this. Preservation and protection of wood and wooden artifacts. In fact, IWST has done two projects, one in Lalbagh and one in Kabban Park in Bangalore, where the sculptures they made wooden artifacts and they were getting damaged. So how do you protect? So these figures, what we have shown in the center, actually basically it was done by IWST, and they are all now doing well. And a protocol was given to the state horticulture department that how do you maintain it. That's all. So this is all the work which we do it, and just a glimpse that what sort of services we give for all of you. And most of the things are known for those who are PG students, and for undergrads, identification of wood, physical, mechanical properties, preservative analysis, formaldehyde emission, and all those things. We have certain specialized facilities also. So whenever you get a chance to visit IWST, I think everybody should see. There are how fire rating of door is tested. You know, in Maharashtra, Mumbai, in any multi-story building, there is a mandate that building should have fire rated doors. So either it should be 2 hours fire rating or 60 minutes fire rating. And for 2 hours fire rating means when you expose door to 1200 degrees Celsius, the still door should be able to maintain that heat and should be. So we have that test facility where doors are fixed and then expose it to 1200 degrees Celsius temperature, fired from the backside, and then you measure any degradation or fire spread and all those things. So these are some of the facilities. So this is what nutshell I was talking about the institute. Now we talk about wood as a bioresource. It's a very scientific answer. Secondary xylem. What is wood? We once we realized that wood can be used as a source of fuel, then only we learned how to cook food. Prior to that, we were not cooking food. We were eating raw. So it started from our journey of civilization and it is there throughout our civilization as an integral part. Okay. Do we have wood age? We have stone age, we have bronze age, we have alloy age, we can talk about plastic age, but we ever call wood age? No, because it was always there. If something is always there, you will not differentiate that this was not there. So this is one of the most important gift of the nature to human beings, wood as a bioresource, which could meet our requirement for fuel, it could meet our requirement for shelter, it could meet our requirement for transportation. The old, even now in Tamil Nadu or all over India, we have bullock carts, wheels, which were made out of wood. And this is what it has transformed our life. So we should consider this as one of the most important bioresource. Now the question is this, to use or now that you're saying use wood, I am also agreeing with you. We should use wood. But we also must know why we should use wood and why it is so important to use wood at this context, at this juncture. We need to understand that when we are talking about climate change, when we are talking about deforestation, when we are talking about rise in the temperatures, in that condition, should we use wood? Because there are two school of thoughts. One, if you use wood, you are going to do deforestation. So whenever I go to school or colleges and I ask them, the colleges, no, sir, we should not use wood because if you use wood, you will do deforestation. The other school of thought is, no, we should use wood. At what cost? First, we should grow wood and then use wood. Okay, conservation is also equally important. Whatever we have, see, our mandate is what? How much percentage area of our geological area should be under forest cover? 33. Where are we now? 22, 23. Okay. We still need to go another 10, 11%. So in that sense, we need to conserve our forest. But at the same time, we also need to produce timber to meet the requirement. We are a growing economy. We are 140 crore people, huge market, huge demand. Okay. So we also need to grow wood and use wood. But globally also, there is no dilemma now. And entire paradigm is shifted. And we are talking about going back to wood. Right from energy to buildings, everybody is talking about using wood. And why? It's because of this. Wood is one of the materials with tremendous environmental benefits. There is no material which could be as environmental friendly as wood. Because we need to think wood as a material. Don't think wood just like branch coming out or anything like which is being thrown outside. Wood is one of the very important materials. Why? Because it has very low embodied energy. What is embodied? Amount of energy you spend in processing something, like the energy consumed. Okay, so like If I take steel and if I take wood, and if I want to process these two materials, which will take more energy? Steel will take more energy compared to wood. That means wood has lower embodied energy. So the amount of transforming or converting or processing, there are lots of literatures are available that 1 ton of wood requires about 640 kilowatt hours of energy to process. 1 ton of aluminum, it requires 125 times more energy than wood. So aluminum is highly energy intensive material. And climate change scenario, we don't want to use energy intensive material because energy means from where will it come? You will again burn coal. You will again burn fossil fuel. Okay, to convert into product. So it has lower embodied energy. The next is carbon neutrality. Any postgraduate student, forestry student, what carbon dioxide released in the atmosphere and amount of carbon dioxide captured in the form of carbon. Most of the wood products are carbon neutral, so they don't emit. Then carbon sequestration. Carbon you are taking, sequestering in form of wood, carbon dioxide. See, trees are amazing chemical factories working 24 hours a day, 365 days in a year. What it does, whatever you exhale as a carbon dioxide, it will take that, use sunlight, water, convert into wood and put in form of wood. So ultimately it will sequester carbon and it is an excellent material to replace other materials. The last point is renewable. What do you mean by renewable? You can grow any amount of time. Today it is over. Tomorrow you cut it, you put another plant, it will come out. Steel, is it renewable material? Once you mine it out, iron ore, convert into steel, can you again generate steel in mines? No, it's not renewable material. So wood is a renewable material. So that is the biggest advantage with wood that you can generate any amount of time. So renew it. Okay. And 1 cubic meter of wood will have almost about 400 kgs of carbon. So that's the carbon sequestration potential of wood, which we need to understand. Okay. So because of this, it becomes a very important bioresource, particularly in current time, because we are storing. See, we need to store the carbon first, we need to sequester carbon, then you need to store the carbon, and then you need to lock the carbon. Now, if I make a wooden furniture, what I am doing is I am locking the carbon for a very long period. See, wooden tables and chairs, generally they will last 40-50 years. See, if I make a wooden table, a wooden chair, I am locking the carbon for next 40-50 years. So that is the great advantage of having wood as a material. Now the question is, what is its potential? I am saying is you can go from nano to mega. That's the vast potential of wood. You can talk about energy, you can talk about big buildings. Yes. Anyone can recognize that building? Anybody has ever observed that? It is a Brooks Common Hostel of University of British Columbia, Canada. It is a 20-story building and 18 stories are completely made out of wood. Only 2 stories are made out of RCC, rest all is wood. Now that's the potential where you can talk about mass timber. Other side, I can make nanomaterials out of it. In fact, one of your student who did PhD here, he has got nanocellulose from pulp, woody pulp, and he has worked on that. So this is the and nanocellulose is a very different type of material altogether. You know what is nano? What is a nanomaterial? One dimension has to be less than 10 nanometer, 100 nanometer. Any one dimension. It has to be less than 100 nanometer. That is called the nanometer. Now, what you are seeing the picture, these are cellulose nanofibers, and their dimension is around 15 to 20 nanometer in diameter. So that sort of material also we can generate. But the thing is, where are the resources? You have three: natural forest, plantations, and agroforestry, what we call as a tree outside forest. Can we rely on natural forest? Absolutely no. That's not the material. What we are left with? Plantation and agroforest. Okay, we all agree with that. We should be using this material only. And when I visited your labs, you have lots of material coming from agroforestry and plantations. Okay, this is the material for future. This is what we need to use it. Now the next question is whether we should opt for few species but range of applications, or should we go for specific species for a specific application? See, countries like USA, New Zealand, see, New Zealand grows radiata pine. 90% of their wood resources are radiata pine. Now, with that radiata pine only, they will make pulp also, they will make buildings also, they will make furniture also. So, only one species, all applications. But we are fortunate enough to have a range of species. So when I today visited your nursery, you have clones of at least 10 to 15 species. So this question needs to be answered that for a specific application, and what Sir has rightly said, say this clone is meant for pulping, this clone is meant for plywood. Same way we can have the clone made for timber. Now then we have Dalbergia sisu, different clones for different applications. Eucalyptus, different clones. So these are some of the questions I think which if you talk to forestry people, they say few species means you are encouraging monoculture. That's not advisable. If you want to go for production forestry and industry, they would like to have monoculture because then you have same type of material in large quantity. So it's again, where do we make a balance? Okay. So this is one of the important thing. Now the questions are, we can talk about all those things that use more wood, but unless until these questions are answered, availability, whether we have enough wood available. Do we have enough wood available to meet our requirement? No. So what do? We are importing. We import quite a lot of timber. We import all the way from one corner of the globe to another corner of the globe. We get material from Africa. We get material all the way from Chile and Uruguay. And another side, we import material from New Zealand, two extremes. And it is all coming to India. We are one of the biggest importers of timber because of the availability. Now, who will make available? People like us. Like our now, this uh, paper industry. Now they are more or less generating their own raw material. They don't depend on anybody. Same way now plywood industry, particle board industry, MDF industry, all these industries will come up. Once they start growing material according to their requirement, then the availability will not be a question. We can solve this question. Variability. What is variability? Why do you want to make clones? Only to tackle variability. Otherwise, trees are all highly variable. One species, other species, it's different. Within a species, there is a variability. Within a tree, there is a variability. So again, this issue needs to be answered. Whether we can produce, and that is why clonal forestry has come into the picture, that you control the variability. For pulping, if I want to create a clone which is having low lignin content and high cellulose, high pulp yield, that is what it is desired. For plywood, the requirements are different. So we need to control this variability. Stability. What is the stability? Stability is very important, particularly for plywood and if you want to use wood for as a timber. So dimensional movement. Wood swell shrinks, it will twist, bend, and all sort of things happens. So that stability becomes an important. And finally, it is degradability. It is good thing also, but at the same time, it is not so good also. Because if I make a furniture and in another 6 months' time, if the powder starts coming, which generally happens, you will blame wood, but not that you have not done the proper process. Okay, so these are some of the questions which we need to address. Now, this is what I don't know. You may agree, may not agree that you have eucalyptus used for pulp, casuarina goes for pulp, Melia goes for pulp, but Melia also goes for plywood and packaging. Silver oak mainly for packaging, composites, rubber wood. It goes as a packaging, timber, acacia for energy and timber. Now my question is, can you use eucalyptus for timber? Can we use eucalyptus for timber? Anybody? This is what I want some PhD student to work on this. That I have converted, I have developed a clone of eucalyptus which can be used as a timber. Fantastic material because it is easy to grow eucalyptus. Can we use it? That is where the science comes. How do we incorporate certain parameters to make it amenable for certain applications? Now, what happens generally? So, all quality depends on two things. Product quality will depend on the quality of raw material and processing technique. So, these two becomes a very important parameter. What is the quality and what sort of processing we have done? Isn't it? For any product, it's the two things which are very critical now. If you want to go and buy even pair of shoes, you will see what sort of quality of the material is being used and what sort of processing as well, like whether it has been done properly or not, and all those things. The same thing for wood products also it implies. Now, what is that wood quality envelope? So I was just want to tell you, for different application requirements are different. For solid wood, you are more concerned about drying defects, you are more concerned about uh, texture, you are more concerned about reaction wood. Can anybody tell me what is reaction wood? Forestry student, what is reaction wood? Have you heard about this terminology? Reaction wood. What is that? Which wood is reaction wood? Tension wood, compression wood, or not? Both tension wood and compression wood are reaction wood. Why it reorients itself? And can you get compression wood in hardwood species? Tropical timbers are hardwood species. So this is what the general difference between angiosperms and gymnosperms. That in one you get compression wood, and another you get tension wood. It's how the mechanism which takes place. Okay. So reaction wood is a big problem in both hardwoods and softwoods. In Melia, we have done studies. You get about 15 to 20% tension wood in Melia dubia logs. Now, if whenever there is a tension wood, you will find excessive shrinkage and fibers will get collapsed. Now that can create problem in veneering also. It can create problem in using as a timber also. And eucalyptus is known for that tension wood. It will have enormous amount of tension wood. That is why it is not preferred for timber applications. I will show you some examples. Like for composites, it's a density, extractive, shrinkage, this becomes, and there are few common things. So like basic density, and I have written one term called MFA. You know what is MFA? Microfibril angle. Have you heard about this terminology? So there is a microfibril angle which is important, and I would like somebody from here to work on microfibril angle because you have resources, different clones. So if we can work, some PhD student can take a work on this to see the variation in microfibril angle in different clones and how it affects the properties, because it also affects the properties in terms of pulping also. So that I think these are some of the quality parameters which we need to work. This is what it happens. This is eucalyptus. Top three. The logs, it's eucalyptus log. The disc is eucalyptus disc. What we did is deliberately we just kept those discs inside a oven and allow it to dry. This is how this V-shaped cracks will generate. And that V-shaped crack is nothing but due to differences in radial and tangential shrinkage. Okay, tangential wood will shrink more, radial it will be less. So when it shrinks like that, it will create a V-shaped structure. The second picture is basically, have you ever tried sawing eucalyptus? Any student, have you thought? Or if you can try, please try here. You have all facilities. Even if you take a small stick about this size and put it in a bandsaw and you just see it, just for fun, you see those strips will go like this. And that's because of the growth stresses which are there in eucalyptus, which are inherent stresses, which comes, it's because of like some people get a lot of stresses. That's because of the inherent nature. And exactly in eucalyptus that happens. In that, you can identify clones which do not go like this. You can breed for that. The core, increment core, you are seeing those two increment cores. You know which species is that? It's Amelia dubia. We were doing some experiment, and from a plantation, we took some increment cores and we thought we will measure density and all those things. And we just kept in oven. And this is how two Amelia dubia cores behaved like that. Do you want to grow this sort of wood? No, because this will not have any economic value. Unless only it can go for particle board or go as a fuel. Otherwise, it will not have either any timber value and it will not even be useful for veneer because it will have excessive shrinkage. So what do we want? We want something like this. This is also eucalyptus disc. Same condition, same process, same species, different family. We again dried it in oven, not even a single crack has generated. Now that is the future of forestry, particularly for plantation forestry. Say those two cores, that is milia, again, same condition, we dried it, they have not deformed. And if they have not deformed, means that is the material which we need to grow. So that is where tree improvement should come, work with wood science and create material which is suitable for different application. See, this is all eucalyptus. See, I showed you one which was going on sighing like this. This log, it is not bending. This log, it is not bending. And this is what we need to grow the material. Now that eucalyptus can be used for furniture. This experiment actually we did, we sorted 49 families and identified 10 families which were not having that defect, which were good in terms of wood quality value. So basically what we need to do is that we need to augment wood resources with defined wood quality. And I'm very happy to see here that this department is already doing that. That you make it for plywood, you make it for pulp. So we know what is the wood quality required for different applications. And I was requesting sir, we should try to do something with timber also, because this is what we require now. In addition to this, we also require material for timber. So what we need to do is that we need to understand wood. What you can do is that classical wood anatomy. All you are anatomist. What you do? You see under a microscope. Okay. This is how wood looks under a microscope. Have you ever seen? One is softwood, another is hardwood. What is the difference between the two? One is having vessels. Can you further see? Okay. Can you see now? This is scanning electron microscopic image. We can go further inside. So all of them are tracheids, isn't it? So it's basically pine wood. If you see hardwood in scanning electron microscope, this is how it looks, and vessels are very, very clearly visible. Now, this science has helped us in understanding wood as a material. Okay, and you can zoom it further. You know what sort of microscopy it has come now? We have transmission electron microscopy. You can go up to 1 nanometer, 5 nanometer, and all those things. You have atomic force microscopy, so you can go up to atom level. We did not try it for wood. Let's try it for wood. Let's go it for there that level also. It will give us a better understanding. Okay. Now this is how it looks. Okay. Intrinsic wood property. You know what is that? It's a pit aspiration happens in hardwood. So pits are nothing but the conducting channel. So from one fiber to another fiber. Okay. And each cell wall is again a composite. So it's a quite complicated composite material. And you can understand the microfibril angle from here. So you go have to go up to cell wall, and in cell wall you need to say how cellulose, crystalline cellulose is aligned with respect to fiber axis, and which we call as a microfibril angle. And this is what the variability you get in eucalyptus and pine where we work mostly. And it's a data of about 10,000 samples. 10,000. So we got it done through CSIRO in Australia. So we got the samples, they did professionally for us, and we used our purpose was to see how variable it is there. And again, there are differences in softwood and hardwood. Hardwoods have lower microfibril angle, softwoods have high microfibril angle. And so this was published in way back in 2000. CSIRO, Krish, yeah, the same person. Now I think CSIRO is also not there. It's gone. It's gone. Now this is how do we assess the wood quality? I have talked about all wood quality. How do we assess? So these are some of the tools. And you, I think your department is going to buy resistograph, isn't it? So once it comes, use as much as possible resistograph. I will request Sir Shekhar sir to give to the student and let them use this resistograph because it gives you the density profile right from pith to periphery. How density is varying. We have to standardize it for our species. That's all. I think that can be used. Electrical resistance tomography is another tool which is used basically to identify hardwood content or defect inside a tree. So you send the electrical pulse and see the resistance. So higher the moisture content, lower will be the resistance. Lower the moisture content, higher is the resistance. Like X-ray densitometry, X-ray diffraction, near infrared spectroscopy. This is another tool. Acoustics, sound waves. That's also another tool which can be used. So like there are a number of tools which are available now to assess the wood quality. Some of them are field operational, where we can do it in field, like Pilodine, resistograph, NIR, ultrasonics, acoustics. They are all field operational tools. So this is Pilodine. Have you ever seen Pilodine? No. So you have Pilodine tool? No. No. So it looks like a gun. So when I was carrying this instrument in Punjab for our field experiment, I was stopped at the airport. Said, what are you carrying? Because it looks like a gun. Then I had to open it, everything, and show it to the custom guys and says, no, no, this is only a forestry tool. But it is very efficient for screening materials according to density classes. Now we have done with lots of material. This is a hardly tool I propose. 2.5. I think we have got. Yeah, I think 6 joule. What 6 joule? You get 6 joule, 18 joules. So 6 joule is very good for Melia, Malena. 18 joule is good for Hardwickia and high density timber. So you can use it. Then we can use acoustics. You know, carpenters, when you talk to them, they will do this and say, sir, wood is good. This wood is good, this wood is not good. Only by tapping. What do they do that? By tapping? They listen to the sound. If the sound is crisp, wood is good. If the sound is not crisp, wood is not good. Same thing we do it scientifically. What we do is that we can hammer a log, capture the vibration signal, and we can tell whether it is a good or not. This we have done for pulping industry. This we have done. Now this sound system is now used by sawn industry to segregate their sawn timber according to modulus of elasticity class if it has to be used for construction purpose. We can also do it in a standing tree. Maybe you can want to buy, you can have this also. It's a very small tool. You can go put it in a standing tree, hammer it, and Kerala Agriculture University they have. Dr. Anup is having, and you just tap one, and you can get acoustic velocity, speed of sound in trunk. Physics principle says the speed of sound in any material is a function of density and modulus of elasticity of the material. It's a physics principle. So since it's a physics principle, it will never fail. Okay, it's a fundamental principle that the speed of sound in any material depends on density and modulus of elasticity. It's a function of only two. So this can also tell you about moisture content. If the moisture content is high, sound velocity will be low. If the moisture content is low, sound velocity will be high. Because modulus of elasticity, again, it's a complicated related with moisture and all those things. We can also do it a very, very small, we have actually used it for even for bamboo. That even you can use it for bamboo. Ultrasound. So you send an ultrasound pulse. You know, ultrasound, they do it for abdominal skin. They'll do ultrasound. What they do is that they send you inside an ultrasound pulse. It gets reflected. Then it creates an image. Similarly, we can also send ultrasound pulse in wood and get lots of information from that, right? So these are all information which you can get from this. This is what we have done with one 9-year-old Melia dubia plantation, which was unknown genetic origin. And you can see number of parameters which we have studied. What is important is this. The hardwood variation was 62% to 92%. Basic density varying from 371 to 551 kilogram per cubic meter. And modulus of elasticity 5.56 to 11 gigapascal. Now that means two-fold variation within a plantation of same age. Now that gives an opportunity for selecting. So for Melia, if I want to select high density, high modulus material, I can go and do selection and then propagate as a clonal material. So this is, we did one experimental trial, and most interestingly, density and acoustic velocity, they are not related with each other. I think that that is again our published paper, so I have not taken that. If you see Mesopsis emini, wood density is hardly about 357 kilogram per cubic meter. Acoustic velocity was 5,000 meter per second. On the other side, Acacia auriculiformis density is 722 kilogram per cubic meter. Velocity is 4,816 meter per second. So two distinct different density class material, same velocity. That means velocity is telling something else. And that something else is microfibril length. And that's what we want to establish, that acoustic velocity tells microfibril angle. It is done for softwoods. They have come out with a relationship. But does it hold for hardwoods also or not? So that's a research problem, fundamental research problem, but it can help quite a lot. Okay. NIR spectroscopy, we have been using, most of the pulpwood industry have been using. The lower picture, what you are seeing is basically distinguishing Dalbergia latifolia and Dalbergia sisu. NIR can distinguish this two very clearly. From NIR, we can identify whether it is Dalbergia sisu or Dalbergia latifolia. So the red color ones are Dalbergia latifolia, blue ones are Dalbergia sisu. So very like the only thing is that you need to do some statistical model, principal component analysis, and all those things we need to do. But it has been a very, very handy tool in determining the chemical composition, assessing physical and mechanical properties of wood, which we can do it. So these are some of the tools which are phased. NI are also field operational. You have tools which you can take it to the field, take the measurements on a standing tree. You don't need to cut a wood sample, nothing. ITC does it. ITC is selecting all their clones using NIR now for a pulp yield. So they say Based on NIR, I can identify material which has high pulp yield. Then wood processing. We have, see, seasoning preservation, everybody knows it, isn't it? You also have a seasoning kiln. But even now, industry says we want it to be fast. We can't wait for 10 days, 15 days. If you follow seasoning schedule, steam heated kilns or oil heated kilns. So then there are options like vacuum drying, microwave assisted drying, or radio frequency drying. These are all methods which can accelerate the drying process. At the same time, it can maintain the quality of timbers. Like softwoods can dry very easily. Radiata pine, they dry it at 100 degrees Celsius in kiln. When 2 days material is out, you put salwood and try to season it. It will not get dried because it is highly refractory to season. Such condition, radio frequency and microwave can be very handy. Though it's still like radio frequency now commercialized, you get radio frequency dryers. Vacuum dryers are also commercialized. In India, we have hardly few. Very soon in IWST, we are going to have a radio frequency dryer. So microwave dryer, we already have one. So where we use microwave, not ordinary domestic microwave. It is having 5 kilowatt magnetrons. So 5 kilowatt magnetron, and you can run it for half an hour, 1 hour, 2 hours, nothing happens. Domestic microwave, you cannot run more than 20 minutes. It will automatically get switched off. Okay. Same thing is wood preservation. You understand wood degradation mechanism. You develop new preservatives. So we don't need to continue with CCA, CCB. A lot of research is being done on plant-based wood preservatives. Then optimizing treatment procedures. This is some of the research. Then what? How do we add value to the material? See, these are some of the new techniques. One is thermal modification. You heat wood under inert environment. Under inert environment means there should not be any oxygen present because then wood surface gets oxidized and it gets charred. If you do heating of wood under vacuum or under nitrogen blanket, nitrogen environment, it will change its color, it will make it dimensionally stable, and it will also make it decay resistant. So that picture what you are seeing is rubber wood. At different level of modification, you can give different color. Other option is why wood is hygroscopic? Because its chemical constituents have lots of hydroxyl groups, cellulose, hemicellulose, lignin, everything. If I replace those hydroxyl group with something else, so if I play with the chemistry of wood, I can make it dimensionally stable, decay resistant. Why termites will eat wood? They find it as a source of food. It's only because of the hydroxyl groups which are present in that. So you replace hydroxyl group with something else, it will not be eaten away by termites. In India, there is one company marketing radiata pine chemically modified wood, Akoya. They sell radiata pine wood at 3,000 rupees per CFT, but gives 25 years of guarantee. It's a chemically modified. It's acetylite, acetyl. If you do acetic anhydride treatment, so hydroxyl groups gets replaced by acetyl group, and then it makes wood dimensionally stable. So this is how you can modify wood, but the opportunity is to convert young wood into high value composites. So we will do now quickly. You all know about these composites, MDF, particle board, plywood, all these are all well known. Okay, so these are all well known. We all do this. But have you heard about cross laminated timber? There's a terminology called cross laminated timber. Anybody has heard? This is what the new things which are coming up. It's a cross laminated timber where you take thick sections, arrange it in like plywood mode, and make cross laminated material. Now the advantage here is that you can go any length, any width, any dimension, and they all are being used for building construction. There is something called mass ply. So this is another one. It is being used in construction. And this is how it is being used in construction. You can see that picture. So you can have roof made out of timber, you can have beams, columns made out of timber, and full building made out of timber. We also dream to have a such sort of timber building. Our plan is that we want to have at least few story building, not 18-20, but at least 2-3 story building. Already people have started making wooden houses. They were there earlier. Now again, but now the thing is, you use for all these products plantation grown, fast grown, short rotation crops. We can make, that is what I was talking to sir. We need Vilia rubia, sawnwood, so that we can convert into CLT. It adds lots of economic value. Okay. And so we this CLT is made out of silver. So our institute, we have used rubber wood, melia, silver oak, eucalyptus, and for comparison, we have also done with radiata pine and chail pine. One of my PhD student for 3 years, he has been working on this. And now we know that silver oak wood gives a very good CLT with high mechanical properties. So this is the area where we need to work, and we need to develop products. So already there are some buildings in India which have come up. Like these are all wooden buildings. One is in Hyderabad, then lower one is in Ahmedabad, where they have used GLT, curved GLT as a beams, and on top of that it is roofs are there. And already one company in Bangalore, they have started manufacturing GLT. One company in Gurgaon, they are making all GLT, LVL based wooden houses. So these things are changing the way wood is being used. And here we are not using any species which are long rotation. These are all short rotation species. Then another aspect is what you do with the wood residue, wood powder. You can blend it with plastic. We can blend it with plastic and make product which looks like plastic. But actually they are having around 40%, 60% wood. The trend is, can we make it biocompostable or bio-based polymer? So these are all, actually we were fortunate enough to work with one industry, a startup company. So all these products are made by that startup company. The startup, and they are now available on Amazon, Flipkart, and finally they are profitable. It's bamboo fiber, bamboo dust, or then they have gone even with rice husk, they have gone even with coffee husk. Anything which is lignocellulosic, it can be blended with plastic and can be converted into these sort of products. In fact, recently when in Chennai we had this chess competition, so they made these chess pawns and they are all compostable. So they use biopolymers along with the bamboo fiber to make this as a biocompostable chess pawn. It's EHA, EHA. You can Google, you can put it on Amazon, EHA. Please make a note. Okay. And actually they have set up their plant was in Bangalore, now they have moved it to Mysore. And they are producing it, making composites. Tell them if they want any financial system, there is going to be investors meets on January 7th. Okay. We can connect it. Right. We will tell them to get connected. Because now they have put two lines. So initially they had put one compounding line, now they have put two. And so their business is growing. And first thing what we did is we made picnic plates. This food. First of 10-15 days, nothing was coming out. Finally, they came out nicely, and I am using it for last 5 years. So they are all food safe material. It's not that. So these, depending on the composition, you can play with the properties, you can make different products. The another thing is, can you convert wood into transparent material? Can you see through wood? This is new area of research everybody is doing. A lot of people are working on that. So this is wood veneer converted into transparent composite. Now it has a different application altogether. We are also trying to use it for, we are talking to a couple of industries where we can take it up for very high end products. These are not meant for low end products. These are meant for high end products. For as a light diffusers, like this tube light, you give us a bright light. But if I want to have a diffused light in the chamber, so generally they use polymer based materials. Here we can use this transparent wood composite. Now, this is one area where a lot of research is being done. IWST, one PhD student has recently completed her PhD in this, and we also got one patent on transparent wood composite, and two more students. In fact, one of the student is from KU, Anish. I don't know, somebody must be knowing Anish. He is about to finish his PhD in this, and he has published at least four papers in very good journal on this area. Now, this is very emerging area of research where a lot of work is being done. Then preparation of cellulose, nanocellulose. Your own alumni here, Dr. Vishnu, worked on making nanocellulose. And what is critical is how stable is that nanocellulose? Is there any agglomeration taking place? And where do we use it? So one of my PhD student right now, she is doing on this work on nanocellulose viscose from different fiber source. So from bamboo, from bagasse, from eucalyptus, from paper, waste paper, converting into nanocellular. And that is where we could see that we are going up to crystalline level and we can get actually single cellulose crystal in that process. So these have different applications. Uh, application. So basically, just wanted to finish it off here that there is a big opportunity here in case of wood. You have forest wood, you can get range of products. It is helping in carbon fixation, it is helping in carbon storage, it is helping in carbon sequestration, and it is giving us so many products. So why shouldn't we use it for different application? But if you want to use it, so this is all theoretical. Okay, renewable, reusable, biodegradable. It's okay. Produce sustainably. The important thing is this. Wood. Yes. And there is a science in wood. How many of you say raise your hands? There is a science in wood. Good.